Hi guys, this will be a very quick video showing another example of fitting a Gaussian mixture model with the EM algorithm. Only this time, the Gaussian mixture will be one-dimensional with two Gaussian with the same mean but different variance. So how does it look? We will have one Gaussian with a variance of 16 and one Gaussian with a variance of 1. And if we plot it, it looks something like this. The histogram and the KDE of this looks like this. And you can see it's kind of a mixture between the Gaussian with the variance 1 in red and the Gaussian with the variance 16 in green. Okay, so if we run the EM algorithm, I already went over this in a previous video. You should check it out. It's called EM GMM example. If we do the EM algorithm, we start with some random values and we finish before the maximum iteration. And we see we get that both the means are almost 0. The variance of one is almost 1. And the variance of the other one is almost 16, not exactly, but pretty close. And the p is 0.5, which is exactly the p that I gave it originally. And we can also see how good it predicted. So if we threshold, remember the EM algorithm gives you the E, which is for each observation, the probability of it belonging to the first cluster. In this case, the first cluster, I think is the square root of 16, I'm not sure. Yeah, it's the probability of being in one and not in the 0th cluster. Yeah, so we can see using this package that I can create confusion matrix of how well it classified the points, how well it identified the points. And we can see it had a pretty good accuracy, almost 80%, but not perfect. So around 20% or 21%, it got wrong. Okay, this is all I wanted to show in this example, this cool GMM that has the same mean but different variance. I hope you enjoyed it and see you in the next one.